All right. Okay, so where we left off yesterday was we finished those two problems with the twins and the tacos. Okay, so let's jump ahead to this question here. The question about subject matter and gender. Subject matter and gender. Okay. All right. So this question here, they give you the two-way table. So we didn't have to last time. The last question we did, we had to create the two-way table. This one, we don't need to. They give us one. So sometimes they will, sometimes they won't. If they don't give you a two-way table, they'll always give you enough information to fill out one. Okay, like they did in the last one. The last one, they gave us enough information where we could fill out all the blanks. If they don't give you enough information to fill out a two-way table, then don't use a two-way table. Okay, it's not a two-way table question. It might be a Venn diagram question. It might be a tree diagram question. Okay, so here we go. Is there a relationship between gender and subject preference? Okay, that's the question. Math or English? The two-way table summarizes the relationship between gender and subject preference for a class of 25 AP statistics students. Okay, so it looks like we have gender. So they're broken up into there was 10 males, 15 females. 20 of them preferred math. That was their preferred over English. Okay, 5 of them preferred English. Okay, and then in between there's some other um, raw data as well. Okay, so this is the raw data, right? Raw data means the actual numbers. There are actually 8 males who prefer math. There are actually 12 females who prefer math. Okay, that's the raw data. That's when I say raw, that's what I mean. The actual numbers of people that were there. Okay, so suppose we choose one student in the sample at random. Suppose I put all 25 names in a hat and I pick one. What's the probability that one are the events male and independent, or sorry, male and math independent of each other? Independent of each other. So what does independent mean again? What does it mean when I say two things are independent of each other? They don't affect the what? The probability of the other, right? Yeah. They don't affect the probability of one thing, right? If I roll a die 28 times, the 29th time it's not going to have any effect on what happened the 28 times before. It's still 1 out of 6, right? So they want to see that. If I tell you, if I randomly pick a name and it happens to be male, is that going to make you think, oh, wait, since it's a male, they more than likely prefer math than English? Or is it not? Is it not going to give you any kind of hint? Okay. So we know that anytime we want to check independence, we have a rule here or a way to check it. Okay. So um, the probability of A given B is the same as probability A. If they're both the same, that means they're independent. It means independent. If they're not, if those two numbers, when I calculate them, are different, that means they are not independent, which means they are dependent. Okay, so let's go back to the problem. It's written on the board too. This part right here is written on the board. So let me write it down. The probability of A given B is equal to the probability of A. Okay. So which one is A and which one is B? Or I can just say math. I don't have to actually, you don't have to use A and B. That's just a more generic term. But we have a math and we have a male that we have to check. So which one's A, which one's B, which one goes first, which one goes second? Or does it matter? Well, if it matters, it has to matter every time. If it doesn't matter, it doesn't matter anytime. So I have A and B, A here. And I'm checking two variables, right? Math and male. So my question is, does it matter if male is A and math is B? Or is male going to be A, or sorry, is male going to be A and math going to be B? or math going to be A and male going to be B? Or does it not matter? It doesn't matter. Yep, it does not matter. We'll do it both ways. Since it's your notes, we'll do it both ways. Okay? So I'll say that male is A and math is B. And then I'll flip it and I'll show you it works the same way. Okay, so in other words, the first way I'm going to do it, I'm going to do it two ways. The first way I'm going to do it is the probability, I'm saying male is A, math is B, and I want to see if that's the same as the probability of male. Okay. All right, so let's do the easy one first. The easy one is just the probability of male. What's the probability of being a male in this class? 10 out of 25, right? 10 out of 25. 50%? 2/4?
No, 2/5.
2/5, there you go. Which is 40, right?
40,
Yeah, that's why I had 40. Good. Okay. The other side, we have to do a little more, we have to do some more calculations here. The other side is conditional, meaning there's a given, right? Anytime there's that line, it's given. Anytime you see this line and you have to calculate anything, your brain or your eyes or both should be going to the general multiplication rule. That's where it should go every single time, okay? Because that's how you're going to calculate it. All right? So the top is going to be the probability of male and math, right? Male and math. So the probability of male and math is what? Male and math. So let me write this down. Probability probability of male and math over the probability of male. So
you don't multiply?
No. The top is male and math. So let's see. AB, but this is A right here, right? A, B, and then equals probability of A, right?
No, and then on the left side of the equation, shouldn't P of male be P of
Oh, down here. Sorry. Math. Yeah, you're right. Should be math.
Yeah.
Yep. Okay. Okay, so male and math. Look at your tables. I can't see my table right now because I'm zoomed in. Male and math. What's the probability of being male and math?
8 out of 25.
8 out of 25, which is 0.32 over. What's the probability of being math? Of being math being their favorite? 20 out of 25, which is 0.8. Use your trusty calculator. Are these both equal to 0.4?
Yes.
They are equal
I
to
got the
0.4.
same answer, but I did it a completely different way.
The only thing I can tell you is you got lucky.
I did instead of. I listed all my points.
It might be a correct method. I don't know. I'm not going to say yes or no because I don't know your method, but there's other ways to do it. But this is the way that I find easiest.
I did like in the top of the division. I did 10 out of 25 times 20 out of 25, all divided by 20 over 25. And then that equals 0.4 as well.
Yeah, I'm going to do it again, and your method might be the way I do it the second time. So I told you I do it two ways because A and B don't really matter, right? A and B, we said A and B, male can be A, male can be B, math can be A, math can be B. I'm going to show you that it doesn't matter which way you do it. So now I'm going to switch them. So now I'm going to say the probability of math given male, probability of math. Probably should do it in blue since I labeled that blue.
So I accidentally used the multiplication rule for independent events when checking for independence.
Let's see. Probability of math given male equals the probability of math. Okay, so the probability of the math is 20 out of 25, which we said was 0.80%. Okay. Now let's do it the other way. So the probability of math and male, still the same number, right? But the bottom is going to be probability of male.
10 out of 25. Oh no, 20 out of 25.
There you go. So it's going to be 0.32 out of
Male.
probability of male is 10 out of 25, right? Which is what?
0.4.
So when I finish that math, do I get the same number?
Yes.
Yep. So it didn't matter which way I did it. Both ways will give you the same number, which means they're independent. The reason I did that is because which one is A, which one is B? It doesn't matter. It does not matter. And number one, male was A, math was B. And number two, math was A, male was B. Doesn't matter. As long as you use the checking for independence correctly, you'll be fine. Okay? You will be fine. They will both always check out. Okay? Or if one doesn't check out, neither will check out. Now, do you have to do both? No, you only have to do one. When you're doing an assignment or when you're doing a test or a quiz or something, you only have to do one. You don't have to do both. I'm just showing you in the notes that both work. Okay? All right.
Tree diagram question. It's just nicer spelling.
Is it? University professor fails 20% of the students will have to get
Well, you said it 50.
after the final he told the students and asked how many of them studied more than 3 hours.
Okay. Tree diagram now. The only one we haven't used on our list of Venn diagrams, two-way tables, tree diagrams, and formulas is tree diagrams. We have never built a tree diagram. Tree diagrams and tables kind of go together. If you can use a table, more than likely you can use a tree diagram. Or if you use a tree diagram, more than likely you can use a table. Venn diagrams don't usually work with these. So two-way tables and tree diagrams are kind of very similar. They look different. They look completely different. One's a table, one's got branches. But if you can use a table, you can probably make a tree diagram. Or if you can make a tree diagram, you can make a table. So sometimes when we're doing problems like this, I'll do a tree diagram and you're like, I used a table. It's the same thing. Okay? It'll give you the same answer. But I'm just showing you just in case, just so that you have that. Okay, so let's read the question. University professor fails 20% of his students in the final. After the final, he polls the students and asks how many of them studied for more than 3 hours of it. Of those who passed, so of the ones who passed, 72% said that they studied. They studied more than 3 hours. Of the ones who failed, 31% said they also studied. Or said they, wait. What did I do wrong? Wait. Okay, so of the ones who passed, 72% that said they studied 3 hours or more. Of the ones who failed, only 31% of those said they actually studied. Okay. So there's two events here. The first event, what is the first event? The final. Yeah. How did you do on the final? Pass or fail, right? So that's where we're going to start our tree branches because that's where it starts. It starts with the final, right? So we're going to build two tree branches here, here, and here. Okay. There's two outcomes for the final. What was it? Pass, fail. One of them is going to be a pass and one of them is going to be a fail. So we can say pass will be here, fail will be here. Okay. What is the probability that they pass? 80%, right? And the probability that they fail is 20. Okay. And then after that, there was another event where he asked the students, did you pass or did you fail? Right? Or sorry, did you study or did you not? Okay, so now we're going to start with the ones who passed. The ones who passed, there was two options. What were the two options for the students who passed? Studied, not studied. Right? So out of the ones who passed, what percent said they studied?
72. Which means the other not percent is 28.
That means 28% said they didn't study and they still passed. Okay. Now fail. There's also a fail one, right? So the fail, there's two options: studied, not studied. Okay. Okay. So those who failed, what did they say there? What did they say? What percent of those studied? 31%. What percent say they failed?
69.
Grow up.
Josh.
It was 102.
Whoa, no. I'm saying I'm part of the ones that studied and failed.
Audrey came over here looking at me like,
No, we haven't even gotten to that point yet. You can't pin that on me. Yeah, it was him that said it. Oh, me.
All right. Okay.
We all
Okay, so here we go. Done. That's everything that happened, right? Every outcome. How many different outcomes could we have?
1, 2, 3, 4, 5, 6, 7, 8.
Not 8.
6.
Not 6. Okay, if I'm a student, what was one thing that could happen to me? Okay, so I could pass, and I studied. So how many options is that? 4. That's only 4 options. Okay? There's not a 6th thing that could happen, right? You either passed or failed, and when you passed, you studied or you didn't study, or you failed and you studied or didn't study. Okay? So there's 4 options there. 4 things, 4 possible outcomes. Okay. So I could pass and study. I could pass and not study. I can fail and study. I can fail and not study. You got all 4 of those? You got them down? Okay. What's that? Yes, that's the quick way of doing it. Just count the last stems. Just count how many stems are in the end. That's the quick way to do it. Yeah. Okay. All right. So we're going to use that to answer the questions. First question: a student studies. What's the probability that, I don't know how many students, didn't say how many students, raw numbers, they just gave us percents. But what's the probability that I put them all in a hat, reach in, pull out a student, and that student studied?
103%.
103%, you said? Yeah.
That's too hopeful.
Yeah.
Okay. All right. So you want me to tell you how to do it? Okay. So here we go. So we said there's how many different outcomes?
4.
How many of those outcomes end with a student studying?
2.
That's what we're going to focus on. We're going to focus on those stems where they studied. Okay. So those stems are right here. That's one of them, right? One path. And the other one is right here too, right? Okay. So when we're using a tree diagram to go down the stems, the branches, whatever you want to call them, we multiply straight across. Okay? We multiply straight across. So if I want to know what's the probability that a student passed and studied, I'm going to multiply those two that I cross. I cross that one, I cross 80, and I cross 72, right? So to figure that out, I'm going to multiply 80% or 0.8 times 0.72, and what do I get? 586? Perfect. Okay. And then that wasn't the only path that led us to studying, right? The path that led us to studying was also here, right? So that path
0.062.
is 0.2 or 20% times 0.31, which was what?
0.062.
62. Does it make sense that the fail and study is pretty low,
Yes.
right? Because if you fail, the chances you studied, not very good. Okay? So, which two numbers represent probabilities of study?
0.57.
Yep. This guy right here and this guy right here. So we're going to add those two guys together. 0.576 plus 0.062. And we get 638. So overall, there's about a 64% chance that the students in their class studied. That tells me what's the overall chances that a student studied, period. About 64%. Okay. Letter B. Letter B says, what's the probability that a student just didn't study?
Couldn't you? Well, we already have one half, so couldn't you just do like one minus 0.638?
Yeah, why can we do that? Why does that work?
You got one variable down.
Why does this work? You're absolutely right. That will work. Yeah, Aldrin, why does that work though? Can you be more specific on why that works?
Because there's two variables. You study or you didn't study. We have the chance of them that they did study, so that's one variable down. So you can just get the other one by subtracting from the whole.
There you go. Right? It's the complement. It's everything else, right? How many paths involve studying?
Two.
Aren't those the other two that we didn't get the last time, right? We can check it out. We can say either pass and not study, right? Or fail and not study. Those are the other two paths. All the paths have to equal one whole, right? So let's double check to make sure we're okay. So that's 0.80 times 0.28 and 0.20 times 0.69. What do we get?
0.362.
First one?
Three.
Three.
I down.
The bottom one or top one?
No, I mean the total. I didn't do that.
Oh, you didn't do each one? Okay, so what was the first one?
0.224.
Thank you.
There.
224. And then the last one's 0.138. Thank you. So somebody quickly add up all four of those. Are they one or close to one? Exactly one? Okay. What if it goes over? What if it's like 0.0001? There's just a rounding, right? It's a rounding. Same thing with 0.9999. It's just a rounding. Don't freak out if it's not one exactly. Okay, so let's add the two green ones. And when we add the two green ones, we should get the same as 1 minus that, which is 0.3 what? Good. Okay. Oh, my tree here. Yeah, let me label it a little better So you can tell. Color code it. Okay. Okay, so let's do question C now. Question C. If a student studies, what's the probability that he passes? He or she, it should say. They pass. Because I'm guessing it's not all males in the class.
57.6%.
I don't know. I don't know.
Oh.
How am I going to do it? I'm more asking how am I going to do it?
Oh.
See if anyone remembers.
0.72 times 0.8.
Why did I underline that?
Oh,
it's the given.
It's a given, right? It's a given right here. Right here. It's a given. That's given, right? They didn't use the word given. They didn't use the word given, but they'll sneak them in like that. It's given. So that's how we're going to do it. Okay? So this is what the question really says. Probability of a pass given study. Or you can just say P and S for pass and study. So on top, it's going to be P and S. We already have that one. Probability, pass and study. And on the bottom, it's going to be probability of study. So what's the probability of, that's a path, right? Pass and study, that's a path. What was the probability? We already calculated it. Yeah, go find the path, right? The pass and study path is the top one, is the top yellow one. Pass and study, 0.576. 576. You can calculate it again, but we did it, so we don't need to calculate it twice. 0.576. What's the probability of studying?
0.638.
Isn't that the one we just did right above it? Right? We calculated the probability of studying. It's right above it. 0.638. .576 divided by 0.638, and I get 0.917. 0.917. That's pretty high, right? We can't go over 1, right? We can't have 120%. We can't go over 1. That's pretty high. Does it make sense it would be high? Why? Yeah, you're right, Kuldeep. Why would it make sense? Exactly. He passed, or he passes. Given he passed. We already know the student passed, right? Or sorry, no, we know the student studied. Sorry, given was the student studied. We already know they studied. It already happened. They studied already. So we know that they studied. What's the probability they're also going to pass? Well, logic says pretty high, right? That's why that percent's pretty high. Yeah.
So when I calculated the probability, I got 0.902.
Did you divide both of those?
Yeah.
Let me double check.
Did you get 902?
Oh yeah. No, yeah. I put the wrong one. 0.576 divided by 0.638, 903.
Yeah.
Yeah, that's why it's always good if two people get the same exact. If two people do the problem and they get the same exact answer, probably did it right. The chances of two people making the same mistake are pretty high, or pretty low, I should say. So yeah, if you get something and the person next to you gets the same answer, tell me if I have a different answer because I probably did it wrong. That's why when I say calculate that for me, and someone tells me, and then I'll ask someone else, it's not because I don't believe them, because I want to know if two people got the same answer. Because if two people got the same answer, I know the answer is most likely right. Okay, so letter D. If a student studies, that's the given part. That's the given part right there. The given is that they studied. He fails. So it's the probability a student fails given that they studied. Your worst nightmare, right? I studied for the test, even though most students that say they studied didn't really study. That's the worst nightmare, right? The worst nightmare is you study for the test and you still fail, right? So what's the probability of that? So probability of both fail and study over the probability of study. Okay. Okay. So what's the probability of the path of fail and study? Yep, the small one, right? The small one. Probability of fail and study is 0.6062 because that's the path there. 0.062. So that one's going to go on top.
Pass. Study.
And what's the overall probability that they study?
There it is.
So you get 0.097.
Yes.
How did I know that without? I mean, I'm good, but I can't do the decimal division in my head. How did I know it was going to be 0.097 without calculating the division?
The compliment.
Exactly, right? Isn't the given part the same? If the given part's the same, they either got to pass or fail, right? So what's the probability of your nightmare happening? Less than 10%. Less than 10%, right? Then it's 10%. Okay? But what's the probability of you being fulfilled because you did well because you studied? 90%. So even though there's always a chance that you could fail if you study, the probability is in your favor if you study. All right, highly in your favor, right? 90 to 10. All right. Okay, so do the next two. If you haven't already, do E and F. Do E and F, and we'll go over it in about 5 minutes. Okay, so I didn't do any of the numbers, but for the first one, the given part is no study. Okay, so given that they didn't study, we already know that. What's the probability that they pass? Or fails for this one. So it's probability of both fail and no study over the probability of a no study. So judging by my list here or by my table here, fail and no study. Fail and no study is 138.138. Okay, that's going to go on my top. And then what's the probability of no study? Yeah, there's two no studies, right? There's a no study here, and there's a no study here. So I got to add up both of these two numbers, 0.224 and 0.138. And what'd you get when you got those? When you added those up? 0.362. And you divide, and what do you get? 0.381. Thank you. Okay. And then pass with no study. Given no study, what's the probability they pass? Well, this number is still going to be 0.362 on the bottom because it's still probability no studying, but passing and no studying is a different path. Passing and no studying is 0.224. 0.224 divided by 0.362 equals 0.619. 0.619, which is the complement of the one we just did, because given you pass, you're either going to study or you're going to not study. Okay. Alrighty. Okay, so what I want you to do now is the next example. I want you to do the next three, A, B, and C. A, B, and C. A is just making the tree diagram. That's part A. Okay. And then use it to answer B and C. Okay, so I'll give you about 5 or 10 minutes. Try it closer to 5 because 10's gonna be pushing it, but because we're gonna go over it. Okay, so here I haven't answered any of the questions, but here is my chart. Here is my, because if you have a good table, if you have a good diagram, the questions aren't that bad, and you use the formulas, it's the easiest you could make it. Okay, so tomorrow we'll go over the questions, we'll go over the answers, but just make sure that you have correct diagrams, have correct pictures, have correct all that stuff. Okay.